President Professor Dr. Abul Ala Hassanin, in collaboration with the Academy of Scientific Research and Technology Egypt, represented by its President Professor Dr. Mahmoud Saqar, the Imam Abdul Rahman University, represented by Professor Dr. Dalal Muhammad Ali Amin Al-Shanqiti, Dean of the Faculty of Science and Humanities Study, and the Federation of Arab Scientific Research Council, represented by its General Secretary, Professor Dr. Mbarak Mohammed. I would like also to thank the organizing committee of this event, especially Dr. Azza Ahmed Abu Ali and Dr. Dabia Ahmed Abu Ainin from the Department of Computer Science, Faculty of Science and Humanities Studies, Abdul Rahman bin Faisal University, and also all the research team of Professor Abul Ala Hassanin. Let me now introduce the Professor Sam Goundar to the participants at his talk. Professor Sam Goundar holds a PhD in Information Technology from the Atlantic International University, Florida, United States of America, and the MBA in Management Information Systems and Bachelor degree in Computer Science and Information Systems from the University of the South Pacific, Suva, Fiji. He has been teaching Information Systems, Information Technology, Management, Information Systems, and Computer Science over the last 35 years at 11 different universities in 9 different countries at undergraduate, postgraduate, master's, and PhD levels. Currently, he is a senior lecturer in Information Communications Technology at British University in Vietnam. Prior to his, he was a senior lecturer in Information Systems at the University of the South Pacific, affiliate professor of Information Technology at Pontificia University, Católica del Perú in Peru, and lectures in Information Systems at Victoria University of Wellington, Malaysian partner campus. As a researcher, apart from blockchain, cryptocurrencies, for computing, mobile cloud computing, and cloud computing, Professor Sam Goundar also researched in network and cybersecurity, social networking, DDoS attacks, education technology, MOOCs, artificial intelligence, ICT in climate change, ICT devices in the classroom, using mobile devices in education, e-government, and disaster management. He has published on all these topics. He was a research fellow with the United Nations University. Dr. Sam Goundar is an editor-in-chief of the International Journal of Cloud Fog Computing, the International Journal of Blockchains and Cryptocurrencies, the International Journals of Cloud Application and Computing, and section editor of the Journal of Education and Information Technology. He is also on the editorial review board of more than 20 high impact factor journals. Please, the participants at this talk can put their question on the tab QR down on their screen. Professor Sam Goundar, you have the floor.
Thank you.
You're welcome.
Right, so what I'm going to do today is I'm going to present about the blockchain technology and how blockchain technology is practiced, and I'll talk about some research ideas of blockchain technologies. So my research agenda is for this webinar is as follows. So I'll briefly introduce blockchain technologies, but I'm not going to cover that in detail. And I mean, everyone associates blockchain technologies with cryptocurrencies and Bitcoins, but what I'm going to look at is other applications of this technology. And then I will give some examples of how this technology is used in the real world, how it is practiced, and what this technology is doing for different industries, different environments, and with different applications. And then I will talk about my focus of blockchain research. And then I'm going to talk about other potential research areas, research ideas of blockchain. And finally, what I want to do is look at some multidisciplinary blockchain research ideas. And then we'll end up with comments, questions, and answers, if any. So let's start off by looking at blockchain technologies, right? And how it all started. That was back in 2008, where someone by the name of Satoshi Nakamoto in 2008 wrote a white paper. And until today, we do not know who Satoshi Nakamoto is. We do not know, I mean, he has been referred to as either he, she, or a group. So we still do not know who they are, right? And in that white paper, what he suggested was that, can we come up with a system where we can have a peer-to-peer cash transaction? Because what was happening at that time, as you would remember, around 2008, what we had was the global financial crisis. Banks had lost millions and billions of dollars of customers because of financial mismanagement, financial abuse, and major banks in US and other places had just closed overnight and told customers that we lost your money. We cannot do much. So the governments had to bail them out and others. So during that time, what Satoshi Nakamoto was thinking was that, I mean, we have trusted a third party like the banks to keep our money safe, but they ended up losing our money. Can we trust them? No, we cannot. How about we come up with a system where we don't need a third party to do these transactions for us? Because at the moment, if I want to pay you through a banking transfer, I will go to my bank, and from my bank, I will initiate a transfer to your bank, right? That's how we change money. That's how we conduct a transaction. So there is a third party involved. We'll call them intermediary for this session. So what this intermediary does is provide the service, but charges us fee. And then we keep our money there and we end up losing them. So what he said was that instead of banks doing these financial transactions and doing this using financial institutions, why don't we use cryptography and code, right? And what will happen is we'll build a network. Everyone can be part of the network. And what we are going to do is send money directly to each other. That will be validated throughout the network, that will be verified for everyone. And a record will be, a block of record will be added to the chain of records, and therefore blockchains. So what he proposed was known as Bitcoin, and Bitcoin really became quite successful. And by the end of 2017, one Bitcoin was equivalent to about 20,000 US dollars. That was a dramatic rise of the value of Bitcoin, and then it crashed, okay? And there are a number of stories and many conspiracy theories about Bitcoin crashing, but that is probably a story for some other time. So what finally happened was that Bitcoins and cryptocurrencies, with the use of cryptography, code, hashing, and algorithms, enable these financial transactions, enable one party to directly pay another party. After Bitcoins, there has been a number of, probably hundreds of cryptocurrencies that have been based on similar technologies, that has been based on the blockchain technology. So Bitcoin was using what is known as the blockchain technology, and that was for financial transaction. And after 2017, when Bitcoin crashed and everything happened, what I did was I shifted my research from looking at blockchains for cryptocurrencies to looking at blockchains as applied to other domains as applied to other applications. So now looking at cryptocurrencies and being able to pay someone online using Bitcoins and other cryptocurrencies was nothing new. In fact, for quite some time, people had been attempting to do electronic funds transaction, that is transfer money to each other using digital currency, but they always had what is known as the double spend problem. And when I talk about cryptocurrencies, when I talk about digital currencies, we are not talking about the funds that you already have in bank in terms of electronic funds. We are talking about a totally different type of currency, a totally different type of cash transaction, right? So what is the double spend problem? Basically, what happens is that within the digital platform, within the digital network, I can announce and I can say that I have $500, right? Everyone knows that I have $500. Now, from that $500, I have spent, let's say, $300. And what remains is $200. Now, no one else knows, because that is what I have announced and that is what I have told everyone. And I have posted that I have $500 and everyone believes I have $500. So what happens is that because my balance remains 500, I can spend that amount again because other people do not know that now my balance has gone down because I've spent $300 for my original $500 amount. With the cryptocurrencies and within the blockchain network, what happens is we are able to take care of this double spend problem because everyone knows about my $500. Everyone keeps a ledger that I have $500. And when I pay someone within my network, this transaction will be validated, verified, and written by someone else. And therefore, once this transaction is verified, validated, and completed, then the ledger on everyone's computer, everyone's network will update to say that Sam had $500, now he has spent $300, and the balance is $200. So whatever I have spent, I cannot spend it again. And therefore, that was one of the breakthroughs within digital currencies and cryptocurrencies with the encryption, cryptography, and code that enabled for peers on the blockchain network to be able to do cash transactions without having the double spend problem. And how was this double spend problem? I'm not going to go into details, but as I said earlier, that what would happen is each and every transaction that took place within the blockchain network would be verified, first of all, to see that I am going to pay someone that amount of money, do I have that amount of funds, just like what the banks do. And once the transaction has taken place, the ledger is updated, and it is ensured that the ledger is updated for everyone so that everyone knows. And then there's hash, algorithms, cryptography, code, and everything else involved. So basically, that was the underlying technology, that was the underlying feature of the blockchain technology. So this is a fairly new technology. There has not been a standard definition. Normally for other technologies like cloud computing and the other technologies that we had before this, there has been a standard definition, mostly from NIST, that is the United States National Institutes of Standards and Technology. But at the moment, blockchain doesn't have a standard definition. So what I've got here is a definition by Tapscott in 2016, where he says that blockchain is an incorruptible digital ledger of economic transactions that can be programmed to record not just financial transactions, and that's where I come in, but virtually everything of value. That is its application not only in financial transactions, but in all other domains. So in other words, you can imagine or picture a blockchain as an electronic spreadsheet that is updated and duplicated on all of our computers. So whenever any transaction takes place, it gets updated on your computer system. So each of us that are part of this blockchain network has an updated ledger where we can see what is happening with all the cash transaction, who has what amount of money and what has been spent, and who has been given paid, and who has been all the transactions updated. Other way of looking at blockchain is as a shared and continually reconciled database. So you can call it a ledger, you can call it a database. And again, it is not stored in a single location. That is, any record that is written is verified by all the peers on the network. There is a consensus. That is another keyword of a blockchain technology. And based on consensus, it is verified, it is validated, then it is added as a chain of records into the block of records. So these are some of the technologies and terminologies that normally people will talk about when they talk about blockchains. That is consensus, verified, validated, peers. And then once the transaction gets recorded, those transactions are irreversible and immutable. That is, it cannot be changed. And that is what we want, because that is going to secure all the transactions. They are going to be irreversible, and that is going to create trust, that is going to create transparency. So this is about cryptocurrencies. This is what happens because it involves money and it involves funds. So that is where the cryptocurrency miners and signers, what they do is within cryptocurrencies, what happens is you run hash and you try to solve a problem that is a difficult problem, and whoever is able to solve this best gets the opportunity to write, to add the record, and even once they are able to do that, they are paid in a newly generated coin. So using hash algorithms and things like that. And this is what has been used for cryptocurrencies, and that is the contribution that Satoshi Nakamoto, the significant contribution that he's made to the field of computer science. So irreversibility creates security, because when a transaction is concluded, a transaction has been made, you do not want anyone to change it, right? That will avoid fraud, that will avoid any corruption. As well as with this blockchain, there is no central authority. So you cannot, there is no possibility of anyone cheating you, because there is no central authority. All the peers within the blockchain network are in charge of all the records and are in charge of validating. And so this is what is known as a decentralized application, or a decentralized decision-making system. So what you might be thinking is that this somewhat sounds like a database. So if databases are doing the same thing, and if database is a ledger, and over the years, over the last 40, 50 years, we have refined our databases, and databases are working well, then why should we use blockchains? Well, simply because the databases have one major constraint, and that major constraint is that that database is managed by a central authority. The task of storing, updating, and taking care of the records and transactions is within the hands of a few entities, for example, your bank. And are you going to trust them? Are you going to trust them with your data? It won't get hacked. Your data won't get shared. Your data, so no one will steal your data. No one will change your data. Going back to my earlier example of where the banks lost all the funds of the customers. So can you trust them? And that's where blockchain comes in, because blockchain provides an alternative. And you can build upon this architecture and remove that trusted authority. And what you are able to do is, because blockchains are replicated across peer-to-peer network, the information they contain is difficult to change. Fraudulent activities are difficult. And even if someone hacks someone's computer system and does something, it exists on everyone else's computer system within the peer-to-peer network. Right, so let's look at some other applications of blockchain. So far, what we have done is we have looked at what blockchains are and mostly applications of blockchains within cryptocurrencies. But this is where my research focus is, that is other applications of blockchain technologies. So what you can see on this slide is that we had this original Web 2.0 apps like browsers, storage, Dropbox, Google Drive, Skype, Android operating system, Apple operating system, social media like Facebook, Twitter, WhatsApp, and so forth. With blockchains, we are developing new applications, new browsers, new storage systems for video conferencing, new operating systems, new social media networks, messaging systems, and so forth. So already there has been a number of developments, and what must have happened is that we must have started just like 7-8 years ago, but within the span of 7-8 years of blockchain technology and development, we have done a lot. So the question is that this is what blockchain technology has done for cryptocurrencies. What else can we do with the blockchain technology? For example, after Bitcoin's success or failure, again, it depends on how you look at it. Some people are saying that Bitcoin's has been a success, and others are saying that it has been a failure because it crashed into 2017, end of 2017, and it hasn't been able to rise again to the way it was. So what I am looking at is that how we can apply this technology to other transactions and within other domains and disciplines and industries apart from financial transactions. So basically, what we need to ask is that, how Bitcoin's operating on blockchain technologies removed the intermediary, the middleman, that was the banks, and people could exchange, that is pay each other directly using Bitcoins. What else can we automate? Or where else can we remove these intermediaries, these central authorities, so that we are able to operate directly, we are able to transact directly, that is consumer to consumer, right? As I said earlier, that what other middleman or central authority can we use the blockchain to retire? And this is where the key is. This is where the blockchain research focus should be. This is where your blockchain research question should align towards. What is the problem? Where are these intermediaries? Where are these central authorities? And can we use blockchain technology to replace them? That is the blockchain research problem and solution. And if you are able to come up with something where you can use the technology to remove the middleman, you have hit the jackpot, not only in research, but in developing an app and making something good for yourself. For example, can blockchain find people offering rides, link them up with people who are trying to go somewhere, and give the two parties a transparent platform for payment? Sounds familiar? Yes, it does. Now we have a lot of apps like that, what we term as the ride-hailing apps. Can a blockchain act as a repository and a replay platform for TV shows, movies, and other digital media while keeping track of royalties and paying content creators? Yes, and we already have something. And finally, can a blockchain check the status of airline flights and pay travelers a previously agreed upon amount if the planes don't take off on time? And we have many apps for that as well. So what you can see is that all these, what we say, these disruptive technologies like Uber and whatever else you have there, ride-hailing apps, Netflix and flight apps and all those things, these disruptive technologies, what they have simply done is they have removed the middleman, right? For example, there are drivers that are willing to offer rides, and there are people that are willing to get rides. So technology has sort of linked them together. And same thing with many of the other apps that we are looking at. So let's look at blockchains in practice. That is how blockchains are being used at the moment. There are many examples, so I'm just going to browse through them and just mention a few of them and how they are being used. But you will see that already this technology and the extent to which this technology is being used and the different spheres, the different areas in which this technology is being used is extensive. For example, already the governments of Dubai, certain states in US, counties in US, UK, Sweden, Ukraine, Georgia, and Ghana, they are keeping land management and land ownership records on blockchain networks. Blockchain is being used in development aid. For example, these developed countries like US, UK, Australia, and others, when they give aid to least developed countries, most of the time it gets abused, mismanaged, or the aid goes somewhere else. So they have built this development aid within the blockchain network so that each and every single cent that is spent will be accounted for. Huge applications in supply chain management and tracking supply chain management in terms of food safety. For example, when you buy a product from the supermarket, you want to ensure that the product contains what it says. People are now going for organic produce, organic products to ensure that it has come from an organic farm. Diamond tracking, you know, there was the story about blood diamonds, so fair trade farmers and things like that. Huge applications within supply chain management. Then renewable energy, power source, microgrids. If you are generating your own electricity, own energy, you can be part of the power grid, and any excess energy you are able to sell to others. Renewable energy. Remittances, so there have been applications like blockchain wallets, Ripple, Bitspark, Moneyfi, and Change, etc. That is going to replace the traditional remittances of Western Union and other foreign exchanges you have, and other remittances systems that you have. And what is going to happen is with this system, probably you will get charged minimal fees, not the typical commission that is being currently charged with the traditional systems. And there has been huge developments in digital identity using blockchain, and again, building a digital identity on blockchain. We'll again talking about the features of immutability, transparency, irreversibility, and therefore validated and verified records that cannot be changed. Other applications in agriculture, food traceability, where does the food come from, fair trade farming, organic farming, food certifications, logistics, and things like that. Democracy and governance, there has been applications. I think countries like Estonia and other countries are already using e-voting systems based on blockchains. Government services, e-government services, provision of that on blockchain networks, smart participation, manufacturing and industrial, smart factories, provenance, checking where your products originate from, able to identify fake products, counterfeiting, helping in verifying products, original ones versus the fake products. Health, huge applications in healthcare, electronic health records, and so forth. Again, transparency, immutability, financial inclusion, microfinance, and so forth. Retail, open bazaar, customer data management, customer relationship management, and so forth. Carbon trading, climate change, environment, human rights, trafficking, refugees, and so forth, access to clean water, and cybersecurity. So these are some, I mean, you can see that under each of the headings, I have indicated the applications that are already available, the application that is already being used, and you can already get an example of blockchains in practice. Within the last 3 slides, you must have seen hundreds of blockchain applications in practice. So I've already. So you might ask the question, why should we focus our research on blockchain technologies? Because at the moment, there is a general feeling among academics and researchers and some skepticism within the industry that this is a fairly new technology, untested, untried, but they were saying the same thing about the cloud computing technology. And look at where the cloud computing technology is today and what the cloud technology has enabled today. But let's look at why we should focus our research on blockchains. Therefore, we can ask, or as early researchers, or as graduate students, or PhD scholars, or academics, the question you might be thinking about it, what is the potential for blockchain research? Well, the growth in size of blockchain networks is increasing, okay, according to Metcalfe's law. That is, it is getting squared in size. There is a blockchain network. Based on that, it gets squared. So 25 blockchain networks creates 25 squared, 25 blockchain networks. So it is increasing exponentially, and it is increasing in size. What about the blockchain market? What about the money? That's what everyone is talking about. That's what the industry is interested in. Where is the money? Show me the money, right? So according to Markets and Market, in 2016, the blockchain market size was 242 million. By 2022, it will be 7.684 billion. According to the World Economic Forum, by 2025, 10% of the world's GDP, that is about 100 trillion, may be on blockchain networks. And for academics and researchers out there, a simple search on Google Scholar for blockchain will indicate that we already have 256,000 articles written on blockchain technologies. Therefore, given all this, we can say that blockchain is a hot and trending topic. It is not a hype, but there are serious implications. There are some serious adoption and market value of this technology. So what I'm going to talk about next is my current blockchain research focus and what I'm doing at the moment, what I'm researching about at the moment. So what I'm looking at the moment is what my research involves at the moment is I'm looking at blockchain smart contracts for totally autonomous supply chain management system. And what is the rationale behind this? Well, I got thinking about this when we went under a lockdown because of COVID-19, because of coronavirus. And we must have all experienced the disruption in the global and local supply chain management, because at the moment, the supply chain management is managed by human beings, operated with human intervention, and it is not totally self-managed, it is not totally autonomous. So when we went under our lockdown and we were told that we cannot go to work, we cannot go to our factories, we cannot go to manufacturing environment, we couldn't go into offices, we couldn't operate the supply chain management system. And because of that, everything with human beings under lockdown, the supply chain system, the logistics, the management, the distribution, the flights and everything also went under lockdown. So what I'm proposing is, what I'm trying to look at is a fully automated supply chain management where the supply chain is managed with smart contracts. Everything that currently the human beings are doing, whatever they're participating in, whatever interventions they are doing, whatever they are doing with the supply chain management system needs to be built within smart contracts. And these interventions are, the decisions that human beings make, the decision that managers make, the decision that CEOs and other top people make, they need all to be built into smart contracts. And based on certain conditions, these decisions will be executed. Smart contracts will be in charge, and smart contracts will keep on running the supply chain system. And if there is any future disruptions, any future pandemics or disasters, this supply chain management system is going to continue managing itself under the execution of smart contracts. And this research is open. If anyone wants to join, you're most welcome. My next research focus is, again, got me thinking, when you are under lockdown, you cannot go to work, you start thinking what you are going to do or what has to be done. So my second research focus that I'm working on at the moment, again, came to me during the lockdown. And this is using blockchain technology for communication, to build, to have a transparent communication system that provides trust, that builds trust, and can ensure integrity, again, during pandemics and disasters. The rationale behind that is, when countries started reporting the number of infections, the number of new cases on a daily basis, the number of deaths on a daily basis. What happened was that there was distrust among different countries, different governments, and different authorities. For example, some authorities, some countries were saying that that particular country is not reporting right, there should be more, there might be more deaths, there might be more infections, but they are not reporting that, they are underreporting, or they are not reporting it correctly. So what I'm suggesting is, why not put all this reporting and communication on a blockchain network, and this network is distributed amongst all the countries, all the actors, peers on the network, and in most circumstances, they automatically pick up records from the hospital's electronic health records or the hospital's management information system, so that it is automated and no one has to manually enter that. That will again eliminate any fraud. And when the borders get open, so people can classify themselves as infection-free. Okay, so you will get a ID number, or you will get a certification number that is part of the blockchain network. And when you go across borders, based on your certification number, they will be able to check you at the border and ascertain that you are infection-free. So the time, money, effort that we are spending on checking people, putting them in quarantine, and checking for viruses and things like that can be eliminated if we come up with such a particular system. And again, invitation is open over there. And my third blockchain research focus is on looking at barriers to blockchain adoption, even though at the moment we can see that there has been a huge number of applications, blockchains being used, but still the uptake of blockchain adoption by many organizations is not at the level that was expected or that was with other technologies. So research needs to be carried out to check what are the impediments, what is stopping organizations and individuals, groups, and everyone from adopting and using blockchains. At the moment, we know that there is a lack of awareness. Not everyone knows about this technology. There are very few successful use cases. Most of them at the moment, even the published research papers, are pilot studies or proposals, frameworks in theory. Very few implementations, very few usages. So again, knowledge, awareness needs to be created. There is regulatory uncertainty. For example, Bitcoins, cryptocurrencies are not regulated in many countries and illegal in some other countries. And then we do not have enough people well versed with blockchains to create blockchains, to code blockchains. And then there is the issue of interoperability. That is because most of the time the blockchain will be used on existing information systems, management information systems, computer networks. And will the blockchains be compatible within these networks, within these operating systems, within organizations' management information systems? So what we need to do is, this is sort of a multidisciplinary research. We can use information systems technology adoption models to investigate, like the technology acceptance model. The universal theory of acceptance and use of technology can be used to study and find out what are the impediments, what are the constraints or inhibitors or barriers to blockchain technology adoptions. Individuals, groups, organizations, and other actors in the IT industry needs to be surveyed to find out what they are. Next, what we are going to do is look at other potential blockchain research ideas. So as I said, that blockchain applications of blockchain is huge in supply chain management. So within that, what we can do is look, research ideas can focus on the integration of multinational organizations that exist within countries. Okay, so if you have an organization and you have branches in different countries, they can all become part of your blockchain network. And again, we know why we want them to become part of the blockchain network is again because of the features of immutability, consensus, trust, and so forth. Product traceability, okay, you know, what happens is that you can use the blockchain network to trace back where the product came from, because what happens is that when the products are manufactured and if the product is added to the blockchain, it is time stamped, and all the other records such as the origin of the product, the place of origin, and other information is added. It can also be used to automate business processes, manage contracts, smart contracts, build reliability and trusted systems, connect disconnected systems, connect disconnected supply chains. Again, blockchain platforms can be used to simplify complexities within different systems by joining them together, becoming the intermediary. Product safety, the ability to detect fakes, and transparency in terms of information governance. Therefore, we are able to remove corruption. The other research idea that we can look at is, you know, why would you want to become, why as an individual, as an organization, or as a group, would you want to join a blockchain network, right? We can understand that joining a cryptocurrency blockchain network is rewarding, because if you are part of the cryptocurrency network and if you are able to add the transaction to the cryptocurrency network, that is, you are able to hash and get mine the coin, you are getting rewarded with you will get rewarded with a newly generated coin. What about the non-cryptocurrency networks? What is the motivation to join, right? So what can happen here is that a research can be carried out to find out the motivation for actors that join non-cryptocurrency networks. What is the reward? Why would anyone want to join, right? And again, we can validate that with we can validate this research with theory of planned behavior, theory of reasoned action, or motivational model. Looking at the application of blockchain in the travel and tourism industry. And our research question can be, can a blockchain platform or network connect customers directly to service providers with the same products and services? Again, disintermediation, like Uber and other ride-hailing services. So what do these websites and intermediaries, or you can call them web aggregators, like hotels.com, Expedia, Agoda, and others you might have experienced or used when traveling or going on vacations or holidays do? Simply, they find hotels for us in a particular area for particular dates, at filtered prices, the amenities, bedrooms, and all this, right? And in doing so, they charge us fees, and they also charge the hotel operators. So as customers and hotel owners, we are both losing out because we are paying them commission, we are paying them fees. And you know, these intermediaries, they are cunning based on demand, based on activity. If you are not in privacy mode, they will know that you are quite interested, and they will change prices at the last moment, right? Based on activity, they will jump up the price so that they can make more fees, they can make more money. So the question here is that, can we develop a blockchain network where hotel operators and owners can join directly and provide information, and we deal directly with them, right? And next, we are going to look at some multidisciplinary blockchain research ideas. So one of them is standardization of blockchains. As we progress with these technologies, different organizations, different groups and individuals are developing blockchain platforms, okay? There are already many blockchains platforms out there, and we are getting new ones on a regular basis. So what is going to happen in time to come is that we will end up with too many different blockchain platforms, each with its own application and each with its own standards. So what is going to happen is that if there is no standard, these different blockchain networks will not be compatible with each other, and therefore we will not be able to join different blockchain networks, and there will be no interoperability amongst them. Okay, already these are some of the popular blockchain platforms like Ethereum, OpenChain, BigChain, EOS, and IOTA, and there are many more. And all of them are developing applications, all of them are developing apps and creating their own standards. So we will end up with too many blockchain platforms. So what we need to do is we need to standardize, okay? Like IEEE standardizes communication platforms and things like that, other standards and technologies. Like any new emerging technology, if we have too many people doing too many different things, there is no compatibility, there is no interoperability. In the end, we will end up having too many distinct systems and different people doing their own things. So we need a standard so that different platforms are compatible with each other and interoperable with each other. And therefore, we need a comprehensive, maybe a longitudinal research with all the stakeholders involved to come up with a standard and an interoperability framework. Next research idea is integration theories, models, and frameworks. So, you know, these blockchain platforms, these blockchain applications will most likely need to work with existing systems because all organizations, groups already have existing systems, management information systems, different operating systems, free and open source systems, which is running perfectly well, but there is disconnect, okay? So if blockchain is going to be an intermediary between different systems, for example, your system and the hotel owner system, or your system and some other system, or one organization's A system with organization's B system, or organization systems with government systems, we need to come up with theories, models, or frameworks that will help us integrate these blockchain systems, blockchain platforms, and applications into existing systems. Okay, because wherever we are going to use blockchain networks, blockchain applications, there would already be existing systems, legacy systems, open systems, or proprietary systems. So how will this blockchain system, going back to my earlier slide, for example, a blockchain developed on, let's say, the Ethereum platform using the Solidarity smart contract, how will it integrate with some organizations' management information systems? How will it connect different systems? Or if there is already an existing intermediary, how it will replace them? And in doing so, what will be the benefits? What will be the value proposition? So as blockchain is an emerging technology, we lack frameworks, theories, or models for blockchain integration. And therefore, research is required to investigate how we can integrate. We can use agency theory or service-oriented architecture. We can use formal methods of modeling and so forth. And then finally, and this is my last slide, if you're getting bored out there, we are looking at social media and user-generated content. And here the research question is looking at, talking about social media, the most common social media being Facebook, Twitter, Instagram, and others, where users create profiles and users create fake profiles and post fake news and then influence elections like the 2016 US elections and others. So how can we prevent fake profiles and fake news on social media? And also, user-generated content that is posted online. For example, again, going back to my hotel example, restaurant example, where customers go visit a particular hotel, resort, restaurants, and they write reviews. And then these reviews get changed. If they're negative reviews, they either get deleted or they get changed into positive reviews, right? So if this information, again, is part of the blockchain network, immutability, irreversibility, and we will be able to identify user profiles and fake profiles, if any, right? So to be using social media, Facebook, Twitter, YouTube, Instagram, and any social media, you have to create a user profile. So once, as a user, you know that you are a part of the blockchain network, and whatever you do can be identified to you. You might not create fake profiles, you might not create fake news, you might not do cyberbullying, and all other this online behavior that we are concerned about, right? So we can detect this, what was posted originally by whom, when, and whether it has been changed, who posted the reviews, and what was the review about, who made this social media post, and what it was about, and we can check the originality of it. So as I said, with the blockchain and its features of immutability, irreversibility, and traceability, it is probably a likely solution, likely answer in preventing fake profiles and fake news on social media and ensuring integrity of user-generated content. Therefore, when a record within the blockchain network, when a record is added to the block, everything is recorded, identified, timestamped, as well as the user's identity. So what we can do is develop social media web portals and others using blockchain networks. So yeah, that brings me to the end of my presentation. Thank you for listening. So questions and comments.
Yeah. First of all, I thank you so much, Professor Sam, for this interesting, rich, and nice presentation. We learn more things from this talk. We have some question, and I don't know, perhaps I can remember the audience of some point that you talked about it. And I think it is a good talk for PhD students, new PhD students that are interested in the blockchain technology. And I remember just that you give us a short presentation about the blockchain technology, and also some real world application of blockchains. And also why focus or research on blockchains, and also you talked about your research in the blockchain technology, and you gave us a lot of research questions, and really I enjoy so much your talk, and all the questions that you asked. I have some questions, but first I have some questions, but first I start with I will see the questions from the participants, and the first one is, what are the required tools and skills to start working with blockchains?
Okay, so what happens is that at the moment, what some of my research students have done is to actually build and develop a blockchain. What you need is coding skills, programming skills, right? So far my students have developed blockchains using Java and JavaScript, and some blockchains on using the Python programming language. But you really don't have to start from scratch. There exist blockchain platforms like Ethereum and many other blockchain platforms that allow you to join and develop with them, that allows development. So basically what you are looking at is programming skills and being part of a blockchain network. If you want to start from scratch, so what you can do is start coding it using a programming language. And then again, what you need to do is, what is required is ensuring that peers get added to your blockchain network. Transactions are validated, transactions are time-stamped, and transactions are recorded. So you will need to write all this information to a database. Okay. What many academics, researchers, and students are doing now is they are not writing things from scratch. What they are doing is going and using this free and open source platforms that is provided by a number of blockchain platforms that you would have seen in my slides out there. So Ethereum is one of those that is free and open source, and there are many others.
Yeah, thank you so much, Sam. The second question, how to merge between blockchain and Internet of Things or Internet of Management technology?
Okay, so what you can see is that there is similarities between Internet of Things or Internet Management of Things, or there is a huge applications of blockchains within industrial Internet of Things. Again, what happens with Internet of Things is that with Internet of Things, what you are doing is you are gathering data, you are collecting data, and mostly you are collecting data with the sensors out there, like traffic lights and smart cities and sensors and different appliances and different devices that has been connected to the internet, and you are capturing data from them. So here what happens is blockchain can provide security. That is, blockchain can provide the encryption that can be used to manage data from Internet of Things, as well as manage Internet of Things. And again, going back to the blockchain features of encryption, cryptography, transparency, and everyone being within the blockchain, verifying, validating, and the blockchain being on peers of everyone that is part of that Internet of Things network. So there has been a lot of work being done with the measure of blockchain and Internet of Things. And in fact, blockchain has sort of being associated not only with Internet of Things, with artificial intelligence, machine learning, and cloud computing, and all technologies out there, because it has some features, it has some functionality that, as I said earlier, like having consensus, irreversibility, immutability, that these different applications, these different disciplines can make use of.
Okay. A third question, Dr. Sam, how do classical blockchain protocols such as proof of work or proof of stake can be used in these new applications? And the other question, are they adequate for this application, or new protocols should be developed?
Okay, so this proof of work and proof of stake is most applicable for those blockchains that manage cryptocurrency networks. For example, they behave differently. When Satoshi Nakamoto proposed the blockchain for Bitcoins, what he said, the concept was proof of work. That is, whoever is able to solve the hash and solve the equation and get the hash will be able to write the block of records, and therefore will get rewarded with a newly generated coin, right? In doing so, what happened was that you were required to get a powerful computer with a very powerful processor, because you wanted to execute, and you needed to take the nonce and run it to get the required number of zeros that was sort of the key to be able to solve the problem and provide that. So what happened was that things really went off track, because people started getting powerful computers, and then the power shifted from the hands of individuals, which was the original idea, to leave the power in the hands of individuals and peers, and the power shifted into corporations, because corporations, organizations, and companies could afford very powerful computer systems. And now they had these server farms mining cryptocurrencies, and individuals could not, because their computers were not as powerful as that. And therefore, like the other blockchain that is getting quite attraction now, that is Ethereum, uses proof of stake, right? With proof of stake, what happens is that it depends, again, within the cryptocurrency network. If you have more coins, you have more power, you have more stake within the network, and you are able to add the record. And again, what is happening is it is shifting the power. So as you get more power and you add more records, you get more coins, and you are getting powerful. And therefore, that is what is known as the 51% attack. So if you get more than 50% power within the blockchain network, you start owning, you start dictating the blockchain network. There is no longer consensus.
Okay, other question?
I'll stop there. Yes, and the second part of the questions, there are now other protocols in place like the Byzantine fault tolerance systems and many other systems that are now giving a fair and coming up with the protocols and systems that is being more fair.
Other question, in your opinion, how we can solve the power consumption in the new blockchain application in Internet of Things? Do you think quantum computing is the solution?
Okay, right. So, I mean, first of all, quantum computing is probably not realistic at the moment, because if you know about quantum computing, you know this computing. First of all, it's very few people at the moment have quantum computers. Like IBM has one, and quantum computing operations are within a confined environment, and you cannot have a quantum computer and operate it in a normal environment. So, but what is happening is that this power consumption that we are talking about, again, is part of the problem of the blockchains that run cryptocurrencies, mining and signing, because there is so much algorithms to run, there is so much processing to be done, and therefore you need powerful computers, you need huge amounts of power, you need different types of cooling system, because it is a race over here. Whoever gets to mine it first, whoever is able to get the hash first, will be able to add the record. So these are applicable on cryptocurrency networks, and these power consumptions, for example, the blockchain network, that is the Bitcoin network, the power consumption is really high, right? And therefore, again, that is why only corporate and organizations can afford to do that. So if you are looking at blockchain applications, again, in the Internet of Things, and blockchain applications in other applications and other domains that I have been talking about, the power consumption is not that high. It is minimum.
Yeah. Now I have some question, please. Perhaps we take more times, but I think the subject is very, very interesting. And all of us today talk about artificial intelligence.
Yeah.
Yeah. And do you believe that artificial intelligence can help for management of blockchain?
Yes. I mean, what is happening is that probably the issue that we have with the artificial intelligence at the moment is what is known as the artificial intelligence bias. Because you know, artificial intelligence will work with the data sets that it has been trained on. I mean, I was watching one of these videos on artificial intelligence bias, and artificial intelligence was very good in recognizing faces that were Western faces of Western people. But Asians and others, the trained data set was not there. So what can happen is that blockchain's smart contracts can ensure that these biased decisions are taken care of. So what you can do is, within your smart contracts, you can program it in such a way that the data sets that artificial intelligence has not been trained to handle would be able to handle them. There is huge opportunities. In fact, the major application of the blockchains and artificial intelligence combined is going to produce a totally new computing paradigm, and is probably going to change the computing landscape and the industry as we know it.
Yeah, another question, please. How to face the scalability of the blockchain in terms of complexity?
Yeah, this is one of the issues of blockchain at the moment, right? So what happens is that as you keep on adding records to the blockchain, the size of your block increases. So we can think about blockchain as a database. And as the size increases, you will get into terabytes very soon. Now, all the peers that are within your blockchain network does not have that type of storage space. So the solution here is to have this blockchain running on cloud and on cloud servers and on server farms. Therefore, what happens is that these cloud servers, these cloud service providers have the capacity. And that again defeats the purpose, because we go onto a centralized. Blockchain is supposed to be decentralized. But if we cannot handle, if the scalability issue is there, that is, the blockchain records become too large, and for example, I am part of the blockchain network, and my laptop that has 500 gigabyte solid disk drive, and as soon as the size of the blockchain becomes bigger than 500 gigabyte, I'm out of the network. What I can do? So scalability is an issue, and at the moment there has not been much done towards the scalability issue, but I'm sure in time to come the industry will sort something out. But what has happened is, you know, the solution that I was giving earlier, that okay, the size of the blockchain is becoming too large. Let's place it on a central cloud server. That defeats the purpose of blockchain. From decentralization, you place it central, it is under the hands of the cloud service provider, and we are back to square one again. So scalability is still an issue.
Perhaps another question, or related question at this question, how also to face the security by using cloud compute, the security of cloud computing by using blockchain.
Okay, again with security, there's two sides of the coin, right? And I would like to add privacy to that as well. So as I said, that the records, when they're added to a block or database as a block of chain, it is secured in the sense that it is immutable, irreversible, no one can change it. It has been written because of verification, validation, and consensus. So the security is there and it is encrypted, right? So for example, if a block gets recorded right now, and after a minute, another blocks get recorded. So the block that was added earlier cannot be changed until the blocks after it. Okay, so if the record is down in the block, you have to start changing everything. And once you start changing everything from the top to get to the bottom, that is digging down, you are going to corrupt the blockchain. So that in that way, blockchain is secure. However, blockchain is not totally private because it is based on peers. Everyone knows, everyone has a record. As I was giving my earlier example, everyone knows I had $500 and I've spent $300 and now I have $200. And everyone, even though they do not know my real identity, but they know my blockchain identity. So that also gives security to the rest of the peers on the network, and that builds trust because no one will go rogue or no one will behave badly because they know each other.
Professor Sam, the last question, it should be the first one for me. We know that there are many kinds of blockchain, like public, private, and sometimes we talk about consortium. Could you please tell us about these kinds of blockchains?
Okay, so first of all, let's start off with what we say we call it public blockchains, we call it private blockchains, and there's the hybrid. There is a mixture of both.
Sure.
Or we call it permission blockchain, non-permission blockchain, or hybrid. So what happens is that in a private blockchain that will operate within an organization, not anyone can join and become a peer on the blockchain. Those that are going to join the blockchain will be invited, and they will have the required credentials to join the blockchain. For example, if within a bank we have a blockchain, we don't want outsiders to be part of the blockchain, because we want to have the decision within our group to decide what to do. Therefore, it becomes a private or permission blockchain. And within this blockchain, again, you can decide who is going to have the authority to add blocks to the chain. For example, you do not want to give authority to everyone. They can be part of the blockchain, they can have read-only access, they can see what is going on, but they cannot add records to the block. Only certain people can, right? And you know who these certain people are, and they have the requirements. They know what are the requirements are to be able to add blocks to the chain. So this is a blockchain, let's say, for a blockchain application in supply chain management. All the stakeholders are part of the blockchain, and this is a private blockchain. A public blockchain would be, for example, the Bitcoin blockchain, the Ethereum blockchain, where anyone can join. Anyone can be part of the blockchain because they want to mine, they want to get a newly generated coin, and they want to be part of, they want to get a coin, they want to get a Bitcoin or a cryptocurrency. And therefore anyone can join, can be part of the network and has equal rights. And then there is this hybrid one where there is both permission and non-permission, private and public. And here in this type of blockchain, what can happen is that certain individuals can validate, can write, and can add, and the others cannot.
I have another question from one participant. Sorry, last question. Do you think there is there is a conflict? There is a conflict between privacy and transparency in blockchain.
Okay, so in fact, it is. I mean, it depends. It all depends on your perspective, right? You are only going to use a blockchain where you want the information to be shared by everyone, and you want the information to be shown to everyone. And that's where some of the applications that I talked about, some of the research ideas I talked about, uses the value of transparency in a blockchain, right? You want to know what is happening, and that's why you are part of the blockchain. However, if you want to keep information private, I don't think blockchain is the platform for you, because blockchain, you will not keep anything private. Everyone that is part of the blockchain network will have access to all the information, right? Whether they are permissioned or non-permission users, private or public users, they will all have access to the information. They will see all the information that is generated, who did what, who wrote what, who added what, and who verified and validated and entered the block. And this is the feature of blockchain, this is the functionality of blockchain that many applications like land registries, land management, and the applications that are shown in my slide can use. When it comes to privacy, there is none on blockchains because all the information is there. However, you can talk about privacy in the sense of information being encrypted, information with the use of cryptography, encode, and the information being encrypted. So what is happening is people are only looking at the records that are being written. But then again, people with enough cryptography skills will be able to decode them. And that's what blockchain mining is about. That's what hashing and solving is about.
We keep many times, sorry for the audience, but if I have a last question and we stop, please.
Okay, sure.
Yeah, can we use a question that we discussed the last few days ago about the clustering? Can we use the clustering in the blockchain technology?
Okay, so
I don't know.
What happens is that this is what is known as a blockchain that gets that starts having different forks. Okay, so and this is where this is one of the issues. This is one of the challenges and problems of blockchains. So what happens is that let's say there is 100 peers on the blockchain, right? And all these 100 individuals are part of the blockchain network. And then what happens is that a few of them, 20 of them, are not happy about what is happening within the blockchain. So within that, what they can do is create a fork. That is, as what I can say is create a cluster. And within that cluster, they can start having their own blockchain, whatever the blockchain was doing, making their own decision, adding records, validating records, and this becomes a problem for the original blockchain. So clustering for blockchains is not good because what happens is that once your whole blockchain gets sort of fragmented into smaller blockchains, you start losing what the original intention of your blockchain was.
At the end, thank you so much, Professor Sam, for your nice talk, interesting, rich,